Learning objectives. At the end of this topic, you will be able to understand the concept of pressure as force per unit area, discuss about the pressure exerted by liquids and gases, apply the concept of atmospheric pressure to explain real-life examples. You have seen that strong winds during a storm or a cyclone can blow away even the rooftops. You also learned that winds and cyclones are caused by the differences in air pressure. Is there any relation between pressure and force?
I don't know, Mom.
Try cutting vegetables with a blunt and a sharp knife. Which is easier?
Sharp knife.
Okay. Do you get the feeling that the area over which the force is applied plays a role in making these tasks easier? The force acting on a unit area of surface is called pressure. The force acting on a unit area of a surface is called pressure. Pressure is equal to force by area on which it acts. Note that the area is in the denominator in the above expression. So the smaller the area, larger the pressure on a surface for the same force. The area of the pointed end of the nail is much smaller than that of its head. The same force therefore produces a pressure sufficient to push the pointed end of the nail into the wooden plank. Let's understand this concept with the help of an activity. Take a transparent glass tube or a plastic pipe. The length of the pipe or tube should be about 15 centimeters and its diameter should be 5 to 7.5 centimeters. Also take a piece of thin sheet of a good quality rubber, say a rubber balloon. Stretch a rubber sheet tightly over one end of the pipe. Hold the pipe in the middle, keeping it in a vertical position. Pour some water in the pipe. Note the height of the water column in the pipe. Pour some more water. Observe again the bulge in the rubber sheet and the height of the water column in the pipe. Repeat this process a few more times. We can find that the rubber sheet has been fixed on the side of the container and not at the bottom. Take an empty plastic bottle or a cylindrical container. You can take a used tin of talcum powder or a plastic bottle. Drill 4 holes all around near the bottom of the bottle. Make sure that the holes are at the same height from the bottom. Now fill the bottle with water. We can find that liquids exert equal pressure at the same depth. We can also find that gases too exert pressure on the walls of their container. We know that there is air all around us. This envelope of air is known as the atmosphere. The atmospheric air extends up to many kilometers above the surface of the earth. The pressure exerted by this air is known as atmospheric pressure. We know that pressure is force per unit area. If we imagine a unit area and a very long cylinder standing on it filled with air, then the weight of the air in the cylinder is the atmospheric pressure. When you press the sucker, most of the air between its cup and the surface escapes out. The sucker sticks to the surface because the pressure of the atmosphere acts on it. To pull the sucker off the surface, the applied force should be large enough to overcome the atmospheric pressure. This activity might give you an idea about the magnitude of atmospheric pressure. In fact, it would not be possible for any human being to pull the sucker off the surface if there were no air at all between the sucker and the surface. The weight of air in a column of the height of the atmosphere, an area 10 centimeters into 10 centimeters, is as large as 1,000 kilograms. The reason we are not crushed under this weight is that the pressure inside our bodies is also equal to the atmospheric pressure and cancels the pressure from outside. Summary. Let's summarize the topic. The smaller the area, larger the pressure on a surface for the same force. Pressure is the force acting on a unit area of a surface. Liquids exert equal pressure at the same depth. The pressure exerted by air is known as atmospheric pressure.